All right, so these are notes for 1.3, other sampling designs. And we have 3 goals today. Follow the systematic sampling process, use the cluster sampling to obtain a sample, and implement stratified sampling with proportional allocation. So simple random sampling is great. So that's from 1.2. However, we may need a more specific method to ensure a, what kind of sample? Starts with an R. Yes, representative. Always got to have that representative sample. Being practical regarding the geography of our sample comes into play as well. So there's like practical pieces and then accuracy pieces that we have to navigate. Systematic random sampling. So I'm using green here. Systematic random sampling is going to be green. We use this method. It's easier to execute than simple random sampling and typically provides comparable results. Each of these methods is going to have a step-by-step process. So steps for this sampling method are step 1, we're going to divide the population size by the sample size and round the result down. That's unique to this method. Round the result down to the nearest whole number m. That's going to break up our population into these little groups of size m. Secondly, we'll use a random number generator. We're not using random number tables this year, to obtain a number k. So that's important. K is between 1 and m. So if you notice in this diagram here that every third person within the group of 4 is selected as being included in the sample. Step 3, select for the sample those members of the population that are numbered k, k plus m, and there's supposed to be a plus sign here, k plus 2m, next would be k plus 3m, k plus 4m, and so on. So we'll take a look at an example. So we did that activity in 1.2. The population size in our activity was 54, but we're going to use 129 considering the larger population of SOA. So you have 129 in your population with a sample. We want our sample to be size 10. We're going to follow those steps from above. Step 1. Divide the population size by the sample size and round down. That's going to be m. Population size here is 129. Sample size is 10. We're going to get 12.9, which leads us to an m value, we round down, is 12. So now imagine these groups have 12 in them. Each group has 12. Step 2 says to find a number k between 1 and m using a random number generator. So you can find any random number generator on your phone, on your Google. So I'm just going to Google real quick, random number generator. Google has its own random number generator here, so I'm going to go between 1 and what? 12, right? Between 1, k has to be between 1 and m. So between 1 and 12, and I'm going to generate a number here. Okay, I don't like that one because it's the same. I don't want it to be the same as my parameters there. 1 would work, but let's go with 3 for this case. So step 2, k equals 3. Step 3 is where we are going to write out which person or item we're going to sample within our data set, within our population. So we're going to start with the number k, that's 3, and then we're going to take that number k and add m to it, so I shift into that next group. So add 12, and then I'm going to do k plus 2 times 12. I'm literally following this process here in step 3. See how it says write down k, then write down k plus m, then write down k plus 2m, then write down k plus 3m. We're going to keep doing that until we get to our sample size of 12. So k 3 and there's a couple 3s in this one. So 3 plus 3 times 12 . 3 plus 4 times 12. 3 plus 5 times 12. I'm going to put dot, 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 because we're going to see how we could do this in a little bit simpler way. So my first number in the sample is number 3. The second one, just add 12, is 15. What's my next one? Be ready with your calculators or just mental math. What's the next one going to be? We're adding on another 12, right? So 24 plus 3 would be 27. 3 times 12 is 36, plus 3 would be 39. And then 48 plus 3 would be 51. And then 60 plus 3 would be 63. We're just going up by 12 each time, right? So then the next one would be what? 75. And then what? Yep. And then what? Adding 12 each time. 99. And then what? Yep. 111. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need 2 more. Plus 12 would be 123. That's too high. Oh, we only needed a sample of size 10. I'm sorry, why was I thinking 12? Pretend like that one's not there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my sample. Systematic random sampling.